Hey there, classes. Welcome back. Yeah, we started with Star Wars on the screen here behind me. I want to give a quick recap of where we've been, where we're going, and what to expect on tomorrow's quiz. So I'll start with the nitty-gritty of the quiz. Our quiz is based completely on the vocabulary that we should have defined. It should be in our notes, and it's an open note quiz. The vocabulary for weeks 4 and weeks 3. So make sure you have that vocabulary down and in your notes. The vocabulary is like our building blocks. As you go up Bloom's taxonomy, that's like the building blocks, and then from there we get a little bit deeper into the subject. And when you're teaching science, it's always kind of difficult sometimes to know exactly where to start because it's like a wheel. You start in one place and then you kind of work your way around and you're back there again. And I say that because you can start with talking about atoms and you can start with talking about forces, or you can start with in biology class, start with cells and work backward. So one of the things we begin with in this class is things like the metric system, how we do good science, how we have, for example, valid experiments versus experiments that might be suspect. And my job is to teach you the science method. I'll talk about that in just a second. And this was on here because we talked about force. One of the things that we start off with today, if you look at the board, there's a lot of quote-unquote facts on the board. And I want to point out that the things on the board are the things that we, yes, have to remember for the class, but it's important that you don't take my word for it. I know it seems silly because, hey, wait, aren't I the teacher in this class? Yes, but no matter the class that you take, no matter what you do, one of the things I love about teaching middle school, high school, and beyond is that you're at a stage now where instead of just writing everything down and saying, okay, well, this will be on a test, I have to remember for a test, I'll go through a bunch of flashcards and remember it. I really want to guide the students into thinking about science as a method, a way for understanding things. Why was Star Wars up there? We were talking about one of the forces of nature, and of course you run into the Force all the time in Star Wars, and we were talking about gravity today. In terms of the aluminum Falcon here, no, it's the Millennium Falcon, but still, as you talk about the Millennium Falcon, we want to talk a little bit about some of the silly things you see in Hollywood, but they're useful for teaching a lot of times because we can point out the things that aren't possible, the things that are possible, and how we know. So if you check out Star Wars behind me, yeah, they talk about the Force all the time there. And that was our jumping off point. So let's jump on in. When we had our brain pop today, we started with gravity. In this chapter, we talk about a little bit about atoms, and one of the things that the book assumes, our textbooks assume, is that students at this level have had a bit of a background in atoms and how they're put together. I would like you to go back on what you know already, but we're going to kind of start going through protons, neutrons, electrons, the basic building blocks of matter. They talk briefly about Democritus and how he had the idea that if you keep dividing things and dividing things, eventually you would get down to something that is not breakable, indivisible, atomnos. When you are talking about an atom, one of the things that sometimes gets confusing for students is talking about, well, yes, it's the most fundamental building block of nature, but then again, we can break atoms apart. This summer, for example, the movie Oppenheimer came out based on a great book. I recommend the book highly. The point is, when you saw the commercial for it, even if you didn't see the movie, you're looking at the results of breaking atoms apart, of splitting atoms. So let's talk about some of the fundamental forces of nature. And as we go through all this, the stuff that's on the board, I am asking you kind of to take a little bit of a leap of faith. The things that are on the board behind me are kind of a bunch of facts. I could have just as easily on the board today put that the world is completely flat and is supported by 4 elephants, and this will be on the test on Friday. And the students, dutifully would have said, okay, this is going to be on the test. I'll just write all this down. At first, during this year, we talked about atoms, we talked about forces. That's why, getting people's attention with, showing the force in Star Wars. But as we do this, I want you to think for yourself, how do we know this? How does Mr. Forbes know, for example, these are the 4 fundamental forces of nature? Don't just take my word for it. As we go through the year, my job is to show you the method by which we know these things. Remember, if you come to this class having known the entire periodic table, and I have had students who have remembered every single element, their symbol, their weight, everything. That's great. But those are science facts. What we're teaching here is the method of science. Facts are great. Facts help us. Knowing things about, for example, every single weight on the periodic table is wonderful, but that's not science. Science is a method for, okay, how do we get there? How do we know what we know? At first in class, I can't say, hey, let's break open our atom and everyone in the class take a look inside your atom, see what's in there. Can't do that. Can't show you protons, neutrons, electrons. But going forward in the next couple of weeks, we do a number of experiments that show that the kinetic theory of matter, that matter is made of tiny discrete particles that move based on the energy they have. I can show you that our idea about atoms is the best explanation for that. When you look at this right here, everything with mass has gravity. We reviewed a tiny bit on Galileo, the birth of science, how Galileo got us going down, the idea that we have to experiment. We have to make sure that if we make a claim, we can back it up with physical evidence. Gravity is one of the 4 fundamental forces that we know of right now. There may possibly be a 5th, 4th of nature, might even be more than that, but we teach in this class what we know up to this point. The thing about gravity is the more gravity there is, the more mass there is, the more gravity there is. We point out sometimes using little Hollywood things like this. Love this model, the Millennium Falcon that zips along. Now, if this was really a spaceship, humans would be about, oh, so big in here. But there wouldn't be enough mass to hold people down to the deck inside. People would essentially be, you kind of think about it like floating inside. In the movies, in Hollywood, Star Trek, Star Wars, what have you, they have this idea that they can have an artificial gravity. That's great because it's a heck of a lot easier to film if the actors can just stand up. But what we're learning in this class is the way the universe works based on the fundamental laws that we're hitting on the board right now. And when you look at a ship like this, it's nice if you could flip a switch and have gravity. They did that in Guardians of the Galaxy. They flipped on and off gravity at will. As far as we know, that's not possible. We can't do that. When we're talking about gravity, of the 4 forces we discuss in here, this is the one we start with. Gravity is by far the weakest force. When you look, for example, at electromagnetism, I've got a little tiny magnet here on this little clip that I use for papers in class. If I put that up on the board, that itty-bitty magnet is resisting the pull of the entire planet that's beneath me right now. So when you look at gravity, it is by far the weakest force. Back to that movie Oppenheimer that came out this summer. Obviously, I'm a big fan of the movie. The book was fantastic, and the movie just did a fantastic job with it. When we saw the forces being released in that movie, the atomic bomb that they show in the commercial for it, remember Barbieheimer? Barbie came out that same week. That is a dramatic example of releasing the strongest force that we know of in nature. And scientists have cleverly called the strongest force that we know of in nature the strong force. So they go in this order. Gravity, by far the weakest. The weak force, we need to know about the weak force going forward later on because that helps govern radioactive decay. And that's important when we get into biology a little more deeply in dating fossils, knowing how old things are. Electromagnetism, more of our everyday force, if you will. We run into this all the time. We'll talk about that a little bit more later. And the strong force, of course, being the strongest force that we know of in nature. One of the things I had the students do today was go back on their moon observation. We had a sheet that got cut and pasted into our notes, and the sheet had to do with, there's the bell, I got to go in a second. The sheet had to do with gravity and the way it holds our moon in orbit, and our moon goes around once per month. Just wanted to show you the notes and remind you that the test tomorrow will be completely on the vocabulary for weeks 3 and 4. Have a great day. Take care and see you online. Bye-bye.